Hi everyone, and thank you for joining our webcast today, How AI Helps Next Generation Vehicles Become More Human. My name is Ashley McManus. I'm the Director of Marketing at Affectiva, and I'll be your host today. With me, I have Affectiva CMO Gabi and Dr. Nils Lenke, Senior Director of Innovation Management at Nuance Communications. So before we begin, some housekeeping items. You can tweet during the event using the hashtag MotionAI and tweet us at Affectiva. If you have any questions during the event, please write them in our Q&A section located in the bottom right of your screen or ask us in the chat box. Technical difficulties, please send us a message through WebEx or email us at events@affectiva.com, and we'll do our best to work with you to resolve the issue as we have quite a few registrations today. Also, please note that we are recording the webcast and we'll make the recording available to registrations before the end of the day. And now I will hand it off to Gabi to begin our webcast.
Great. Thank you, Ashley. Hello, everyone. My name is Gabi. I head up our marketing and product strategy at Affectiva. Ashley and I are in a very rainy and stormy Boston today, which is a bit odd given it's almost July, but thank you, everyone, for joining us online. Before I kick this off, I also wanted to highlight for you that we are kind of planning this ongoing series around AI in automotive. We have quite a number of interesting folks registered today out of the automotive industry, and I just want to do a call out that if ever anyone has an interesting topic or is interested in presenting themselves, we're very keen to host guest speakers rather than just have Affectiva folks speak. So if you're interested in presenting your own work or talking about a kind of a topic around in-cabin sensing and AI in automotive, we'd love to host you, and just reach out to Ashley, please. So today we're very pleased to have Dr. Nils Lenke of Nuance Communications. We've been working with Nils and his team for quite some time now, and we share a joint vision of what kind of the human-to-machine interfaces need to be in our next-generation vehicles. Great progress has already been made in the vehicles that are on the road today, but both Nuance and Affectiva, we see lots of room for improvement, and we're currently exploring collaborations, and Nils will talk about that in a lot more detail. Just for a little bit more background information, for those of you not quite familiar with Affectiva, Affectiva spun out of MIT Media Lab almost 10 years ago, out of that group where the field of affective computing was started. At Affectiva, we really kind of coined emotion AI, we pioneered the field, and emotion AI is essentially AI software that can detect emotions and cognitive states as well from human faces and voice. We use a large amount of real-world data to build our AI algorithms. Of course, we use machine learning and deep learning to do so. Coding heuristically for all these complex and nuanced emotions and cognitive states is just not feasible, so that's why we have such a focus on deep learning. But also, I want to highlight, this is not just a kind of R&D type project. We've actually been in market with commercial products since about 2011, where 1/4 of the Fortune Global 500 and more than 1,400 brands have standardized on our technology to do their ad testing. Our technology and our SDKs are used in a number of markets to emotion-enable apps, devices, and digital experiences. And more recently, in the past year or two, we've been very actively engaged with the automotive industry as a large number of OEMs and Tier 1s are proactively reaching out to us to collaborate on what in-cabin sensing and emotion AI can mean in the future and in next-generation vehicles. We, at the beginning of this year, launched our automotive solution called Affectiva Automotive AI. It is the first in-cabin sensing AI that is multimodal, that can analyze both face and voice channels to infer nuanced and complex human emotional states and cognitive states such as drowsiness and distraction. We do this mainly for two use cases. On the one hand, to improve road safety by monitoring drivers for impairments, again, drowsiness, distraction, but also to help deliver an optimal transportation experience and a differentiated kind of in-cabin environment, which you can really only achieve if you measure the mood and the reactions of people in a vehicle to what's going on around them in the car or in another type of vehicle. So that's our focus on automotive AI. I would like to quickly highlight for you that in September we are organizing again the Emotion AI Summit. This year's theme is Trust in AI, which many of you will certainly in the context of automotive see resonate a great deal, because building trust between humans and vehicle AI is a big challenge, and it's getting a lot of focus in the industry today. We're running this September 6th in Boston at the Stage Room, a beautiful venue in downtown Boston. We just opened registration last week, so if you're interested, please check that out at emotionaisummit.com. We'd love to have you there. Without further ado, I'd like to introduce Dr. Lenke. At Nuance, Dr. Nils Lenke leads a team that's focused on disruptive innovation in the car, and they're especially working on multi-modality of human-to-machine interfaces in the car and exploring new hardware architectures that go alongside that. So Dr. Lenke does a lot of work liaising with partners in the automotive ecosystem and the academic world, and he himself holds a PhD in computational linguistics, computational linguistics, 2 master's degrees, and 1 diploma in computer science, and a number of patents that have been awarded. We're really pleased that Nils was available today to join us and share his vision. And Nils, I gladly hand it over to you now. Thank you.
Yeah, thank you, Gabi, for the nice introduction. Hope you can hear me. Thank you for having me. I hope you can see my slides, and if that's the case, I'll go ahead then.
Please go ahead. It looks good on our end.
Okay, fantastic. So, a few words about Nuance, and Gabi, I liked how you brought up our name in a subtle way in your slide, saying the nuanced emotions you were talking about, right? So, we are the company called Nuance. Many of you will know us. We earn our money exclusively with technology that helps human beings communicate with technology in call centers, in cars, with smartphones, and so on. And today I'll only talk about the automotive space. So the automotive division is a division within Nuance. We are totally focused on serving the automotive industry. In the slide you can see a few of our, or many of our OEM customers and also of our Tier 1 partners, because we work through Tier 1s a lot, but we also more and more work with OEMs directly. We do $250 million in revenue only in the automotive industry. Nuance as a whole does $2 billion annually, but automotive is $250 million. So we actually spend quite a bit of time on technology in the car, and we so far have equipped 180 million cars with technology. And one thing I need to share here, I showed the same slide a couple of weeks ago, and today I got a mail by a colleague who said, well, Jaguar Land Rover complained because their logo is not up here. And that's true. They're our customer. The logo is missing here. We'll add it. But what I like about this, when I started on my job and we started setting speech recognition and so on, you had to beg customers so you would be allowed to display their logo. And today they complain to you when you do not, right? And I think it shows also the importance of AI, communication in cars, building assistants. So it has become a lot more important to all the OEMs, and they take a lot of interest in this topic. Moving on to the next. So this is our mission. You may never have heard about a Nuance assistant or a Nuance automotive assistant, and that is because our goal is to partner with the car manufacturers and their Tier 1 partners to build their automotive assistant. So what we try to do is supply technology, assistance, our know-how, and help them build an assistant in their car that allows their drivers to communicate with their vehicles. And we're not always visible, but you can assume that nearly always when you have a car that's speech-enabled, there is some nuance in there. And we'll come back to this topic of assistance in a bit. I would like to review a couple cases to see where does this stand today. So this is a quote from a publication from a couple years ago. It was when BMW launched their new voice-enabled system, initially in the 7 series. By now it has been rolled out also in the 5 and 3 series. And it's really a nice system because, first of all, it combines embedded and cloud ASR and NLU. So what it does is it runs speech recognition and natural language understanding on the head unit in the car, and it also invokes the cloud where appropriate. And that's in a seamless way, so the driver would not even notice if something is handled in the cloud or in the car, which is important for example, situations where you don't have connectivity. And speech recognition has advanced a lot over the last few years, so today you can do it all in one menu. So you no longer have to walk your way through the menu and say, well, navigation, destination entry, and then give the address. Today you can say, well, navigate me to stateroom in Boston, or set the temperature to 65 degrees or something, and all at the top menu. You can do barge in, so you don't have to wait for the car to finish their TTS prompts to the end. You can just barge in. We combine it with handwriting and other things. So it's really a very nice system. The one thing I want to point out here is that the journalist here doing this piece called it a voice activation system, right? He does not talk about an assistant. It's voice activation in the car. Now let's move on to a more recent system. You may have heard or seen the new Mercedes A-Class, where they put a lot of emphasis on the new user experience, which is called MBUX, which has a very large touchscreen and a very nice speech-enabled system, which is supplied by Nuance. When you saw how the car was announced at CES or in Amsterdam at the event, it was really interesting because very little was said about, say, the engine of the car or other technical features. The entire time was spent by their CEO, Setche, to speak about the MBUX experience, which shows how important this element is in cars today, how important it is for people who drive cars to stay connected, to have a good user experience, to be able to talk to their cars or manipulate in other ways, because cars today are also very complex. And again, very nice for us here is that Mercedes runs ads that they talk about our technology, and I'll try to show this ad here.
Hi, Mercedes. Yes, please. I want some German bread. Please select an entry.
Hi, Mercedes. It's too hot in here. Can we make it more East Coast?
I am setting the temperature to 62 degrees.
What is their wedding chapel in your suggestions? Hi, Mercedes. Navigate me to what 3 words? Drive, single, beat. Hi, Mercedes. Where did Jeff drive us last night?
To shop, Las Vegas.
Okay, so I mean, it's a nice ad. It was done for the Las Vegas event, as you could probably guess. A couple interesting things here. So first of all, the BMW system still had push-to-talk, so you have to push a button. Here in the Mercedes system, which is also a hybrid system, all-in-one menu and all that, but it has a wake-up word, so you can say, hi, Mercedes. And that's interesting because it's much closer to the assistant experience people are used these days from, say, smart speakers or other devices where you can also wake up these assistants by a name and saying their name. And this is the same model here used by Mercedes, which also shows they want to keep the other assistants out of their cars and have drivers talk to the Mercedes assistant, and we're happy to help them there. So really things moving to the assistant experience. Now, 2 very nice systems. Does it mean we are done yet? I mean, do we have the perfect assistant in cars? And in order to get to an answer, I'd like to compare what we do in cars to human-human communication. And to do this, I'd like to introduce a model about communication designed already 100 years ago nearly by a psychologist called Karl Bühler. He was German, moved to the US later on and worked there. And he said, well, communication is between me and you, and we talk about things or the world, right? So he has three aspects. There's a sign or a symbol in the middle. You have the sender, you have the receiver, and you have entities and facts. So it's really I, you, and the world. And there are functions between there. So the sender expresses themselves, and they do an appeal to the receiver. We try to achieve something when we talk to somebody. We want them to do something. We want them to create a mental image. So really do an appeal to them to act on what we do. And we reference and represent things in the world, entities and facts. So that's his communication model, and I want to use that to analyze where we are and what's still missing. But first of all, is it even appropriate to apply a model that was designed to describe human-human communication to human-computer interaction? And I think that's a fair question because, I mean, you could say, well, a machine is a machine. We don't communicate with them. We interact with them. They're just machines, and we should not try to pretend there is a human being you're talking to. And that's a position some people can take, but it's a very hard position to defend if you look into it. And the reason is that this is not how we humans operate. So if you look at it, for hundreds of thousands of years, when humans communicated in speech, they could be sure there is another human being they're talking to because there was nothing else that could do speech, no animal, no artifact. And so for us, it's very clear that when we speak to somebody, it's a human being who also has cognitive processes and has reason he applies. And that's a principle already figured out in the 18th century by a guy called Johann Heinrich Lambert. He called it the hermeneutic principle of charity, which means when we read something, even if it looks confused or if we hear something and it doesn't sound right, we try to assume the other side meant something by saying or writing this, and we try to figure out the meaning. And as it turns out, this is something that then psychologists discovered around the turn of the century or the millennium, is that we cannot stop doing that. It means when we hear speech, we always assume there is a human on the other side. And even if we know we are talking to a machine, we still project certain human traits into the machine, and that's called anthropomorphism. So we see the machine as having certain traits that typically humans have, and we just can't stop doing that. That's behind the fact that people find it cute when you have a speaking robot, etc. So it's really hard to not do that and see the machine as just a machine. And that has a few consequences. So first of all, there are studies showing that because it happens, if you have an autonomous vehicle that can talk, people have more trust in it. So trust is driven by this anthropomorphism. But it also, of course, it raises the expectations. I mean, users assume somebody can talk, they're also clever and smart, and it raises the expectation of what the system can deliver. And for us, people who try to design systems within cars and elsewhere, it means we need to make sure to live up to the expectations. So what we try to do is focus on delivering an assistant who is really good at talking about domains relevant for drivers, like parking and fuel and all of that, and finding a restaurant or hotel, but not necessarily trying to build a general assistant being able to talk about everything. And then, again, anthropomorphism is here automatically, which means we don't have to create it by telling jokes, something that sometimes people do. And there's a study here with Sarem, showed that people can actually react quite negatively to that. And many of us will remember Clippy, the unfortunate attempt by Microsoft to help us all creating documents and all of that in the 1990s. It has been called the most hated virtual assistant in the world, and because it was so intrusive, right? It would pop up on the screen and be proactive, and many people hated that. So it really means you need to really think about how much you need to push anthropomorphism because it's already there automatically, and we need to be very careful what we do there. And then, of course, it means we need to better understand how human communication works so we can try to rebuild that in machines. So let's look again at Wheeler's model and how we can apply it to human-car interaction. So first of all, a lot of what happens today is on the right-hand side, and we'll return to the left-hand side in a bit. But even on the right-hand side, what is really good today is we have the representation and the appeal. And in our terms, that's intent and named entity. So the appeal is really intent. I talk to the system and say, please find music by Ed Sheeran. And that's a command. My intent is to find the music, and that's the appeal I do to the system. And I mention Ed Sheeran, so the system needs to know who he is, and that he is a music artist. And that's the named entities we talk about. So that works quite nicely. Even the other way around, if the system talks to us, like in navigation, it says take a left turn at the right traffic light. Again, same scheme, right? It's intent, wants us to do something and mention something in the world. And even in the ad, if there are statements like, well, I'm hot, the system takes it as not the person expressing themselves as being how they feel. It's rather, it's a command to do something about the climate control, right? So the appropriate answer is setting the air condition to 21 degrees. So that all seems to work quite nicely, but there's lots of things missing here. And the one is that humans, to start with, do not only talk about the world and things that are there by words. Instead, if you look at it, a fully fledged communication is where the participants can see each other. They use things like gestures, head pose, gaze. We see where the other person is looking at. We have facial expressions. We are together in an environment that we both can see, and all of that, as you can see in the left-hand side. And on the right-hand side, you can see a very poor communication that only has to rely on speech only, like in a telephone conversation. There are lots of problems there, right? You don't know how the other people react, like pretty much like what I do. I'm talking here. For all I know, many of you could already be asleep or something. I don't see that, right? Which makes my experience here a lot worse than speaking live. And that's the same thing that people have also in other situations. So it really means that we need to get back to the full experience on the left-hand side. And that, for example, means you do a lot of pointing in the world, and Wheeler again found out that we have lots of linguistic devices doing that, like we say, well, here versus there, this tree versus that tree, left, right, and all of that. These are pointing devices we use when we point things out in the real world, but also in mental constructs that we both share. When I tell you, well, if you come out of Prudential Center and walk down the street, you will get to Charles River in a while or something, right? I mean, probably not true, but you know what I mean. And also we can point within text or dialogue. And so we do this linguistically, but it's also combined with pointing with either our hands or our eyes, right? I mean, we can even do pointing with our eyes, without our fingers, and without beams coming out of our eyes like Superman has. We don't need that. And it's really quite an achievement we humans do. It's something that puts us apart from other animals, as we'll see in a bit. So we really can point with our eyes. And if you've ever wondered why our eyes look the way they do, biologists found out that we are the only species having a lot of white and dark contrast in our eyes, which is really a disadvantage from an evolutionary perspective if predators are after you in the dark. So there must be an advantage to make up for this disadvantage, and that's really that it allows other humans to detect where we are looking at, which means we can coordinate, we can hunt together, we can do things together, and we all know that, right? I mean, if somebody is talking to you but not looking at you, looking elsewhere, we immediately detect that. So we are really good at that as humans. That puts us apart from any other being, including primates, whose eyes look very different, as you can see. So we said we can exploit that. So we built technology for the car, a solution that we showed at CES this year, where you can have a device in the car. You can see it above the steering wheel. It's a prototype. And you can look at things outside the car, and you can say things like, what are the opening hours of this shop? So you see the linguistic device, this, combine it with the gaze, and the system will pick it up and will give you information about that shop or that restaurant. It's also combined with just talk, which means I already talked about the progression from push to talk to wake up word, but we have taken it a step further. So we now allow technology that you can talk to the car immediately without having to press a button or saying a wake up word. And then we call that just talk. And the system knows what is a command to the system and what is a discussion between you and the passenger. It can distinguish between that. It works quite nicely. People typically are skeptic when they hear about it. When they experience it, they like it a lot, and it goes nicely with the gesture and the gaze here because you don't have to press a button first. So in order to build that, you actually need quite a few elements. You need the eye tracker that keeps track of your eyes, and again, it's a technology also Affectiva uses. They have cameras and computer vision to pick up other facial expressions. We'll return to that. And here you have a use for the camera where you pick up the gaze orientation and the head orientation. We combine it with a 3D model of the environment that we built on top of maps, like from here or other providers. You need to know where the car is, and then you can figure out what the object is somebody is looking at. And you can then return information about it from the assistant in the dialogue system in the car. So that's what we built. At CES, we had it as a static demo with a projected film on the windshield. In spring this year, our two events in Detroit and Baveno at the Lago Maggiore, we showed it live on the street, and I'll show it now.
What's the name of this place?
Baveno Yacht Club is a social club located opposite the Borromean Islands with stunning views. The historic clubhouse has a restaurant and a terrace bar overlooking the lake, ideal for events and social ceremonies.
Okay, I think you get the idea. We are now progressing this further as a product, and it will be a good first step to bring more of the multimodal experience, the visual dimension into communication. But there is more missing. Let's return to Bühler. So now let's get to the left-hand side of this graph. So the whole expression dimension is missing so far. And here's two situations, right? The system could be the speaker, and the driver could be the speaker. We need to distinguish. So when the system is the speaker, should the system express emotions? And we'll look at that a bit. When the user is the speaker, they automatically do it. You cannot speak without expressing your emotions and cognitive states. People will see if you are tired, if you are distracted, if you are stressed. You can pick it up from my voice. If I believe in my story, if I'm nervous, you will hear it immediately, right? So we really cannot communicate in a neutral way. And so our systems need to do the same thing and detect the user's emotions from video, from speech, and then need to react to these emotions, because that's also what humans do. So how can we do this? We call it affective computing, very similar to what Affectiva does. Again, three things need to be done here: detecting emotions, reacting to emotions, and expressing emotions. And I'll do them more or less in reverse order. So expressing emotions, the system design can do this via dialogue. Like a dialogue can express style and mood. It can be a very brief and short dialogue. It can be very verbose. So how you structure your dialogue, how you phrase things, is already one thing you can do. And then on the right-hand side, the voice quality. We can mimic that also with technology. Nuance, we also build text-to-speech or speech synthesis, which used to be very robotic in earlier years, and today it becomes very natural. We also can put some emotion into the voices, and you'll see this here in an example. This is what we call emotional TTS and multi-style voices. So it's the same voice built with the voice talent. but it has two styles, a neutral one and a cheerful one. And I'll play the examples and you'll hear the difference.
Chicago Cubs win World Series. Their 108-year championship drought, the longest by any major American sports team, finally came to an end after an 8-7, 10-inning victory over the Cleveland Indians in a thrilling Game 7 that began Wednesday night and ended early Thursday morning.
Okay, so same voice, but a different style.
This year's disappointing loss against the Cubs means that the Cleveland Indians, who last won the World Series in 1948, are now the team with the longest dry spell between championships. Hopefully, they will be able to break the streak of bad luck in 2017.
Okay, I think you get the concept, and we already have a project here with an OEM who want that, so you can expect TTS to become more like this in the future, so it can express emotions, and you can steer that based on content, or as you will see in reaction to what the user's emotions are.
Chicago Cubs.
Sorry. What about reacting to emotions? Assume we wouldn't know what the emotional state of the driver is. What could we do? So we built a system here together with Toyota and their concept iCar, which they showed at CES also and Toyota Motor Show, and plan to show during the Tokyo Olympics. It's a concept car in many respects, design, technology, and all that. The element we delivered is, again, speech recognition, natural language understanding, and some reasoning. It gives a highly personalized experience, and it's also emotion aware. So one thing it does is, when you drive around in the car, it knows what the context is, where the situation of the car is, and it will provide information proactively. And it will say, hey, Jonathan, we'll be passing by the Tokyo Aquatic Center. I think you're interested in this. Should I take you there today? There is an event going on at 2 p.m. It does it based on emotion awareness. I need to say, in this case, it was very, very basic because it only picked up certain vocabulary items by the user of the system and tried to guess the emotions from there. Why do we do this even? Again, I said earlier, proactive behavior with systems is not trivial. As we saw in Clippy, some people hate proactive behavior in automated systems. So it's only appropriate when the driver is open to it. And we try to pick up how they react, if they're in a good mood, if they're in a cheerful and chatty mode. And then we do the same in our dialogue, and we provide more information. If they're terse, we also don't provide proactive information. So that was a concept we did for Toyota. But as I said, very basic detection of emotions, which clearly is not good. So we thought, what can we do more? Obviously, what you want to do is to get a sense of the driver emotions and potentially the passengers by using other sensors, and not just the vocabulary, but also by looking at speech and facial expressions. And to come up with a full model of the user, either the passenger or the driver, their emotional and cognitive state, are they drowsy, are they happy, etc. And you need technology that does that from speech and facial expression via video. So who is good at that? Obviously, when you heard Gabi earlier, and you knew it before, it's Affectiva. So we had this quite emotional bond immediately when we started speaking to each other. So we thought combining our assistant and the speech recognition technology and Affectiva's emotion detection is a good combination. And we are working on joint use cases. Some of them are safety related, so detecting like unsafe states of the driver, responding to it, also very relevant for autonomous vehicles. Is it a good situation for transfer of control? Do I need to alert the driver or not? Is he already actively following, etc.? You need to adapt the dialogue, as we saw, to the cognitive load and emotional state of the driver. Then we just want to provide a better assistant experience, like mirroring the emotional state of the driver, like you pick it up in emotion detection and you can use appropriate TTS voices, as we saw, and the styles of these voices. You can detect frustration of the system with the assistant and respond. So lots of interesting use cases. And we'll be we are working on them actively. We'll be demoing them at some stage, and so please stay tuned. We'll keep you updated how that progresses. The one thing to see here is that, first of all, the automotive assistant needs this. We saw this earlier. If we want to be in human-like communication with the driver or passenger, we need this emotional dimension. We need to know what the driver's emotional state is to create the optimal experience. But the reverse is also true. If you only do emotion detection, say from video or from voice, it doesn't help you, because what do you do with the information? Yes, you detect somebody is drowsy or they're not happy, so what do? Display yet another icon in an already overloaded GUI, and driver is likely to miss it? No, you need an assistant that can react in an appropriate way and do something with the information. So it really goes together hand in hand, and that's why we are so excited to work together with Affectiva on this. Quick summary. So I spoke about that automotive assistants are quite good today, but they're mostly speech only. There is inevitably some anthropomorphism. So it's okay to apply principles of human-human communication to HMI, and we did that by analyzing what it's missing. Going into the multimodal extension with gaze is an important step to a true multimodal experience, and that's what humans also do when they speak to each other. And it's close to being on the road in technology now. And then, of course, taking emotions and cognitive states into account is the next big thing. And we need to cover the expressive side of the communication, the left-hand side of the Wheeler model. And emotional TTS and emotion detection are important building blocks. And Affectiva and Nuance are partnering to create really compelling use cases around them. And please stay tuned. We'll talk a lot more about that once we're ready. So thank you very much. Happy to take questions, and then also if you want more information, stay tuned. Here's some contact details. Also connect with the LinkedIn account, Nuance Automotive, to get more updates. Thank you very much.
Okay, Dr. Lenke, thank you so much. It was a fantastic presentation. We're getting a few questions in for you, so I'll field the ones that we have time for. And reminder, if you do have a question, please use the Q&A chat box on the bottom right of your screen, and we will answer them if we have time. So the first one for you is, from your experience, which emotions can be effectively sensed to be a voice, and which ones are challenging?
Yeah, so that's really more a question to the Affectiva guys who have a lot more experience there. Clearly, there is differences also when you use video and voice. Some expressions you can pick up more easily from video and some from voice. I mean, use your own judgment. What is it you can pick up? We as humans are pretty good there, and I think technology can more or less reflect that. But really, it's a question more to Affectiva to answer that in more detail.
Yeah, and this is Gabi. I'm happy to kind of take a crack at that. So in our experience, and we're definitely gathering more data and testing more, but essentially when we're focused on building technology that can detect emotions from face and voice the way humans do, right? And when you're building that type of technology, it essentially really comes down to getting large amounts of contextual and relevant data so you can train your algorithms on that. So right now, for example, kind of fairly low-hanging targets are things such as anger and joy, also because those occur quite frequently. So when you're gathering and collecting data to use to train and validate your algorithms, that type of data is easy to find. For us, it's been relatively easy to build those classifiers quite quickly. Things such as frustration, and then also notions of stress even, right, are a bit more challenging because it depends on context. And if you think about stress, how do you even define stress, right? What does that really mean? There's no textbook definition of what stress is. So you need to start kind of putting a stake in the ground and looking at use cases and context, and then target data collection specifically to that. So in that sense, that is more time-consuming and more evolved to develop. But Affectiva's stance is that in principle, if we're able to collect the data and annotate the data, we can build for any emotions. So Nils, if you have any thoughts or anything you'd like to add to that, please chime in.
No, I think that's great.
Okay, our next question, how do you inject emotion and cognitive state into non-voice systems?
Well, that's a good question, and I mean, it shows the strength of speech and voice here because it's a natural medium to do this. I mean, you could think of things like avatars and virtual heads and faces also using mimics to express emotions, but of course the danger in the car is that this will distract drivers. So I think unless we can combine it with virtual reality, augmented reality, holograms, etc., just doing it on a GUI screen may not be the right thing. And again, it shows the quality of voice here, which does not distract drivers as much and is a very natural way to express emotions.
Okay, next question. To modulate the generated voice according to emotion, what parameters are you using besides pitch or speed?
TTS technology today is based on neural networks, and the neural networks are again trained to find, based on examples, how to do it, and they really affect lots of different elements of the voice. It's not just two elements, but it's really spread over all the features we use in text-to-speech synthesis. It's not just listing one or two elements.
Okay, I think we have time for one more. So, there's a couple more coming in. Okay, so question that crosses my mind immediately is the cognitive state of the person behind the wheel with respect to keeping a neutral emotional state and how to overcome that barrier if it is one.
So again, I think it's very hard for us humans to not express any emotions, and so you have to have facial expressions, and if you try to control those, if you want it, it's very hard to do it on voice only. And the nice thing here is, if you have a speech assistant, you get people to speak, right? I mean, if you drive alone, you don't have a speech assistant, you might be driving for 2 hours and not say a word. But if you use your voice to control the car and select music, navigate, etc., you already have the person speaking, and you can then pick up the emotional state from those utterances to the system. Of course, if there's passengers, it's a lot easier, but even for single drivers, the speech assistant creates these speech events that we need to pick up emotions. And it's very hard for humans to avoid saying that. But I mean, obviously, we don't want to supervise or monitor drivers for our sakes. It's to make their life better. And I would imagine that most OEMs would make this configurable so you can switch it off if you don't like it, right? I mean, we are not trying to be Big Brother here. It's just to make a better experience. If some people would opt out, just so be it.
Okay, one last question. How well does your technology work when there are multiple passengers that are conversing inside a car's cabin?
Yeah, that's a good question, and again, there's two elements here. If you have cameras, you can see who is speaking. You can use that information, and you can pick up the different faces and take the information from there. But also on the audio side, with Nuance, we have a technology called speech signal enhancement, or SSE, which is a beamforming algorithm working with a microphone array. We can very much beam in or focus in on the one person speaking and combine it also with voice biometrics. So recognizing who is speaking from maybe 4 people in the car, and then zooming in with the beamforming and only pick up the signal from that one person, routed to Affectiva, who will pick up the emotions from that very speaker.
Okay, great. I think that's just about all we have time for this event. I want to thank you, Nils, for your time today and for all of you joining us and for your questions. We tried to answer as many as we could, but it was an amazing webcast. I certainly learned a lot from, and I hope you did too. We did record today's presentation, so you should receive an email shortly with the recording. For details on our next webcast and other upcoming events, please follow us on social media, and keep checking our events page, and sign up for our monthly newsletter at affectiva.com. And as Gabi mentioned earlier in the webcast, we did just open up registration for our in-person event, the Emotion AI Summit. That will be September 6th in Boston. We invite you to join us for a full day of content and networking as thought leaders explore this year's theme, Trust in AI. You can find more info and register there at emotionaisummit.com. Thanks again, and have a great day.